So today we are going to be doing a little lab to test the law of conservation of mass. And the actual experiment that we are doing is one that is pretty commonplace, but the concept that of course we're testing is very profound, as it affects all of chemical reactions throughout. And so what I have here set up today is my main ingredients are going to be baking soda and vinegar, an experiment that many of you have undoubtedly seen before in the past and are pretty familiar with. But if we do this right, hopefully we're going to be able to make a pretty good test on seeing whether the law of conservation of mass holds true. In front of you, you see the equation there. Baking soda is sodium bicarbonate, NaHCO3. We're reacting it with vinegar, which is a form of acetic acid, or CH3COOH. And we're going to create, or the products that we will come up with are going to be carbon dioxide, water, and then you see the sodium acetate at the end. And so that is kind of, in a nutshell, the experiment that we're going to run. Now we're going to do it though in such a way that hopefully we can get some pretty good measurements and give it a pretty fair test. First thing I want to do here today, if I follow my instructions, I'm going to measure out somewhere between 6 and 8 grams of my baking soda. So I turn on my scale. Oh, kind of reset it here. Give it a second. There we go. And the technique that I'll use, of course, as per normal, I'm going to put a little watch glass on top of the scale, and then I'm going to go ahead and add my my baking soda or my sodium bicarbonate. Oh, I'm going to redo that because I forgot to tear the scale. If I go this way, instead of subtracting the difference, I'm going to be able to just hit tear, and then I'll be able to see when we get somewhere between 6 and 8 grams of it. So I'll drop it on in here. 3.69, we're getting pretty close. There we go. We're within the range now. Just we'll get right about to 7, maybe a little bit more than that. 7.61 grams. And so the first bit of data that I want to keep track is I got 7.61 grams, or 60 grams of my baking soda. What I'm going to do is I'm going to put that into my little sandwich baggie here. All right, my little sandwich baggie. I'll drop that in here for storage, and put the watch glass away. Next then, I'm going to measure out 15 milliliters of my vinegar. This is vinegar. It's nice clear vinegar. So we see it well as I drop it into my graduated cylinder, right to 15. Good. And the vinegar we're going to put into this little plastic dish. Most of you probably don't even see these anymore. This is a film canister. Back in the good old days, before digital photography, we actually had to use these to hold our film when we would take pictures. Well, next then, what I'm going to do is I'm going to find the mass of the snack baggie that's got that has the baking soda in it. I want to find the mass of the vinegar and film canister. Try to center this a little bit more. And there's going to be a second bag, another second Ziploc freezer bag that we're going to put everything in as well. And with that, I'll try to see if we can't hold that in place, keep it all on the scale well. That doesn't want to stay folded. We're going to give it a go. And we see 32.96 grams. 32.96 grams. That is going to be my initial mass. 32.96. I'll put that down on my data table. Next step can be a little tricky, but we're going to try to make it happen pretty well. I want to get this baggie opened, and I'm going to put the film canister in here. But I don't want to mix them yet. I don't want to mix them yet. My goal is to try and catch any gases that are escaping in the reaction in the bag. And so this sandwich bag here, I'm going to try to squeeze out the air as best that I can. So all I have in here is pretty much just my vinegar and baking soda. Squeezed out pretty well, and then I'm going to seal that off. Now these little sandwich baggies do a decent job of holding things, but to improve our catching of the gas, all right, I want to make sure I don't tip this over and spill it. I'm going to put it in the freezer bag here as well. And the freezer bag is just a little thicker plastic. I can get a little better seal, really try to do a little better job catching. All right, now I have in my freezer bag, I'm going to try to go ahead and squeeze this shut good and tight. Camera mount in my head. Guide on me there. I have to flip it around here for a second. Sorry about the, hope you don't get seasick there. All right, so now squeeze this bag, squeeze the air out of this bag too. And then try to seal it up as best we can. See how our mass compares just a second here. It's kind of wobbling here. .98, stayed pretty much the same as what we measured before, so that's a good sign. All right, well now, at this point, what I want to do is I actually want to spill the vinegar into the baking soda and let this reaction take place. So I'll go ahead and tip this over. And now inside here, you see the bag inflating. Bag is inflating as the reaction goes. Bubbles are forming. And if I touch it, as I touch the reaction, suppose it feels hot or cold. First instinct a lot of times it'll be is it gives off heat. Well, in this case, it actually feels pretty cool. We talk about endothermic versus exothermic, but you can see how the bag inflated with gas in there. Well, let's see what it weighs now. See how it held true here. 32.67. Okay. After the reaction, so I'm going to write that down into my data table. The difference then, 32.96 minus 32.67. You math whizzes are probably already on this, but that's going to be 0.29 grams. 0.29 gram difference from before the reaction and after the reaction. All right, so that's kind of what we were shooting for, to kind of see were we able to conserve. Obviously, there was a slight change in mass that took place. Okay, what the percentage of that was, probably quite minimal, but a little bit seemed to change. Now, what I want to try to do next is something a little bit differently, a little different. I'm actually going to go ahead and light up my Bunsen burner. All right, and I'm going to actually mix or open this bag up. I'm going to open the bag up, and then I'm going to go ahead and light up a little wood splint. Get my wood splint on fire. There we go. It helps if I have a lab partner, but I don't. And when I put my wood splint in here, look what happens. It goes right out. Put my wood splint in there. Out she goes. Well, why is that, you might think? Well, look at the products of my reaction and think about that, solving it that way. You'll also notice that when I opened it up, whatever gas was formed did not escape. It stayed there in the bag. Now I want to see how much gas was in there. So I'm actually going to try to squeeze that gas out of here now. All right, squeeze it out. Get rid of it. I know that it weighed 32.67 grams. 32.67 grams at the end of the reaction. Let's see what it weighs now after I pushed as much of that gas out of there as I can. I'll see if I can seal it up again so we don't have anything spill out. $32.48 grams. And so a lot of times we don't think of gas as having a mass, having a lot of mass to it. But clearly, some of the mass is lost when the gas is given off. And again, I can do a calculation to find that change in mass. For me, it happened to be 32.67 minus 32.48, just going to be 0.19 grams. And then there's some little bit of mass, some calculations to do as I calculate the mass, how much the total mass in my experiment was gas. Now with that, I can start filling in my assignment. Okay, some observations that I made. Okay, certainly I saw a reason a chemical change occurred. I saw that a gas was produced. I saw the bubbles being formed. Okay, I also saw a change in energy. it cooled down. The bag got cold. Those are both signs that a chemical reaction might have taken place. Well, if instead of giving off heat and heating things up the outside, if it absorbs heat, that reaction would be what we would call endothermic, because it pulled energy in. Was there a change in mass from the initial to the final mass? Yes, there was. Okay. There was. We saw that 0.29 grams were lost in that reaction. Okay. When I opened the bag, did the gas leave the bag? No. Okay. It stayed in the bag. Okay. It put out the burning splint. Put out the flame like a good fire extinguisher would. And that, of course, means that it has a greater density than air, because otherwise it would have flown out when I opened up the baggie. Was my hypothesis correct? Well, that depends on what you said for your hypothesis at the beginning. If you thought that the conservation of mass was going to be preserved, well, pretty much we saw a little change. Okay, a little change in there. How much of a change that is, you can argue that it's certainly well within the parameters of experimental error. If you said that it didn't hold true because you saw that, well, defend your position. Do you think that these baggies are 100%, airtight, that no gas could escape in the experiment? All right. Or where else could have there been some change in our measurements? Maybe in the scale. You notice how the bags kind of hang off the edge, and depending where I hold it, that can affect the mass reading on the scale as well. All right. So when you argue the last questions here, do you think that it held true or not? Well, I would say it did, because I feel like we can explain away the slight change in the mass that was seen, just based on the techniques and the materials we had to work with in this experiment. We'll let you finish that up. Thank you for your attention. Have a great day, and go Ponies.